Hello, my dear students. I hope you're all doing well. My name is Benatang Paton, and I welcome you to the channel Classroom, where we learn together. So today I have a very interesting topic. The topic is Joule's law of heating. Now, this is a very important topic, and I want each and every one of you, to understand this topic. A student of class 10 should understand this topic because it is so exciting. You ask me now, this is so exciting. This is very important, and believe me, me as a teacher, I'm telling you, if you understand this, it's gonna bring excitement in you. So this is a very interesting topic. In the whole topic of electricity, this is one topic, besides Ohm's law, this is one topic which is very interesting, and I want the enthusiasm, the energy which I have in me right now to be transferred to you. So I want all of you, to understand and listen and learn from this video. So enough of the excitement. Let's jump and let's learn the topic with enthusiasm, zeal, and energy. So Joule's law of heating, very important. Very important. This is very important. So I cannot specify on the immense importance of it. So believe me, it's very important, and it is so exciting also. So grab a notebook, pen or a pencil, and you know what to do. Write down everything which I scribble in the whiteboard, because these are going to be valuable notes for you. So without wasting any time, let's go to the topic now. So the first thing that I want to discuss is electrical energy and heat energy. This discussion is important because we cannot directly go to the Joule's law. Without preparing you, I cannot start teaching about Joule's law. So I need to prepare you. So preparation is very important. To achieve anything, we have to prepare. If you don't prepare, you will not achieve it. So preparation is very important. So this is electrical energy. This is heat energy. So electrical energy and heat energy. Both are two different forms of energy, but do you know, my dear students, that there is a relationship between electrical energy and heat energy? Yes, there is a relationship between electrical energy and heat energy. Now, to emphasize, and then to support this point, I'll tell you some common examples which you have experienced up till now about this relationship. Most common example is when you charge your phone. When you charge the phone, you have plugged in the charger and you have been charging your phone for, say, an hour. You go and remove the phone. You go and take your phone. You will feel the back of the phone heated up a little bit, not extremely very hot, that it will burn you, but you will feel the warmth underneath the back of the phone. Yes or no? Yes. What is that? That's electrical energy converting to heat energy. Electrical energy gets converted to heat energy. Other examples which I can give you are mixer, grinder, laptop, computer, and all that. All these devices, while performing their duties, what happens? They tend to get heated up also. Though they are not heating devices, they tend to get heated up. Why so? That's because electrical energy can give us heat energy. So are you ready now to learn more about this interesting topic? Yes. So let's go. So let's erase this and let's learn more about what I have just told you. And Joule's law, Joule's heating law, will tell us more about that. So let's learn Joule's law. Now, before we write the statement, remember, Joule's law will tell us the factors on which heat produced in a resistor depends. So Joule's law will tell us the factors like how much heat can be produced or how much heat is produced. So Joule's law will shed light on the factors on which heat produced in a resistor depends. So let's write. So the statement goes like this: heat produced in a resistor is directly proportional to the square of the current flowing in the resistor, comma, resistance of the resistor and the time period for the flow of current, close inverted commas, open inverted commas. So this is Joule's law of heating. Okay, let's read the statement. Joule's law of heating states that heat produced in a resistor is directly proportional to the square of the current flowing in the resistor, comma, resistance of the resistor and the time period for the flow of current. So let's try to understand in detail, okay, what Joule is trying to say. So let's suppose we take a resistor. So let's take a resistor having resistance R. This is how you draw resistance, okay? So it has got resistance R. Let's say that current I is flowing through the resistor for a given time period T. Now, what will happen here? This will produce heat energy. This will produce heat. Okay, this will get heated up. So it will start giving out heat. So it's getting heated. It's giving out heat energy. Okay. So Joule's law helps us to understand the factors on which heat produced in a resistor depends. So Joule's law tells us, okay, the factors on which heat produced in a resistor depends. So the heat produced in a resistor, according to Joule's law, depends on the square of the current, the resistance of the resistor, and the time for which the current is flowing in the resistor. This is what Joule's law tells us. Joule's law tells us the factors on which heat produced in this resistor depends. Remember this, okay? It tells us the factors on which heat produced in this resistor depends. Remember, this statement is very important. So let's write down here. So we will convert this law into statements like this. So according to Joule's law, heat produced in a resistor is directly proportional to the square of the current. So current का square, which can be written as I square. The heat produced in a resistor is directly proportional to the resistance, which can be written as R. The heat produced in a resistor is directly proportional to the time period, which can be written as small t. So Joule's law can be written as like this in the form of statement. Now all of these combined, we will get one statement, and also we will get one very important formula, which is very, very important. So let's derive the formula. So we will get H directly proportional to I square R and T. Yes, they are all directly proportional, isn't it? So we are just writing the same thing only. Then next step, we have to remove the sign of proportionality and bring the sign of equality, for which we have to bring a constant, because that's how it is done. So H, bring equality, but bringing equality, you have to bring a constant also. So which constant we will bring? We will bring K. So we bring K, and then the rest will remain as it is. Now what we will do is, we will assume that the value of K is 1. So assuming K to be 1. Now if K is 1, if K happens to be 1, Now see, anything multiplied with 1 is the number itself. So 1 is here and 1 multiplies with 10. So what is the answer? 10. 1 is here and this is 5. So what is the answer? 5. So it is very clear that anything multiplied with 1 is the number itself. So if k value happens to be 1, then this 1 will multiply this value. So the answer will still be this value only. Yes or no? So the answer will still be I square RT. This is it. So this is the formula which I was talking about. This is a very, very important formula for calculating numericals. We need this formula if the question is asking us to find heat produced in a resistor. So this is Joule's law, giving us a very important formula. Now, like I told you earlier, that Joule's law tells us the factors on which heat produced in a resistor depends. But do you know or not that Joule's law does not tell us why heat is produced in the resistor in the first place? Yes, Joule's law does not tell us why heat is produced in the resistor in the first place. So this is a very important question, is not? So then let me ask you, how is heat produced in the resistor? So how is heat produced in the resistor? Yes, anybody tell me, how is heat produced in the resistor? Yes, correct. The answer is because of collision. So heat is produced in the first place in the resistor because of collision. So the reason why heat is produced in the resistor in the first place is because of collision. So heat is produced because of collision, and Joule's law tells us the factors on which heat produced in a conductor depends. But Joule's law does not tell us why heat is produced in the resistor in the first place. So I want you to be very clear with this, what Joule's law tells us and what Joule's law doesn't tell us. So remember, Joule's law doesn't tell you how heat is produced, but Joule's law tells you the factors on which heat produced depends. I hope you are clear with that. I hope there is no confusion, because students tend to confuse, So I want to make this clear, that Joule's law does not tell you, why heat is produced in the resistor in the first place. Joule's law only tells you the factors on which heat produced in a resistor depends. And now I only told you that the heat is produced in the resistor because of collision. So the electrons which carry the charge, they are moving at great speed. Now they are moving at great speed. That means they have got tremendous amount of kinetic energy in them, because kinetic energy is the energy associated with moving particles. So these electrons have high kinetic energy in them. It's almost going to be morning. What is the time by my watch? It's almost 1 only. So why the crowing? So let's come back to our topic. So the electrons moving at high speed, having high kinetic energy. Now what they do? They collide with each other. When they collide with each other, the kinetic energy gets converted into heat energy, and in the form of heat energy, it goes to the surroundings and gets wasted in the surroundings. So the heat energy goes to the surrounding and gets wasted in the surroundings. But there is a way to utilize this heat energy. So this wasted heat energy which is lost in the surrounding, there is a way to utilize this heat energy. And the next topic will be about how we are utilizing the heat energy. So the next topic is going to be very, very important. So let's go to the next topic, where we will learn about how we are utilizing this wasted heat energy to our advantage. So let's go there, for which I'll have to erase this and write the topic. I record these classes late at night because during daytime there is lots of disturbance. So by now you must have noticed, my dear students, that there is less of noise. I try to make sure that there is less noise. Okay, so I record this when others are busy sleeping. Okay, see how much effort I'm putting. Okay, so yes, okay, I'm putting a lot of effort so that you can all benefit from these classes. Okay, so I'm much grateful if you're learning and if you're tuning in every now and then. Thank you and keep it up. So the next topic will be heating effect of current. So the next topic will be heating effect of current. So let me just write it down. Heating. Okay, applications of heating effect. Heating effect totally discussed. So the next topic is applications of heating effect. Applications. This video may be a little lengthy, but then it is going to be very important. Applications of heating effect. The first device that we will be studying under this topic will be the electric bulb, or simply bulb. So let's study the bulb. Now, do you know what a bulb is? Because I am asking you this because nowadays we don't see bulbs a lot. Okay, inside our home, it's all replaced by LED bulbs. So where will you find a bulb? Yes, when you go to the market to buy chicken, okay, you will see the bulb, because these poultry farmers, they use the bulb. So next time you go to the market, see the yellowish bulb. Okay, I call it the Thomas Alva Edison bulb because it was invented by Thomas Alva Edison. Okay, and this is used. We don't use it anymore. Like I said, everything is LED. Okay, save energy and all that. So LED only. But energy saving is very important, so we have to save energy. But here, okay, this bulb, it gives you the yellowish color, okay, which is almost similar to the sun. Okay, I say creativity, we are losing creativity. Okay, originality and creativity, we are losing it, because the previous items were very retro and very original to the concept. Nowadays, okay, I don't know what type of innovation we are going on, but then things are changing. Okay, now though we are living in white light, but our forefathers, they used to live in this yellow light, which resemble the sun. See how genius, how ingenious, how genius they were. Okay, now we are living in neon LED light, isn't it? So everything is neon LED. Now let's not go off topic now. So this bulb, okay, if you see this bulb, you will find that there's a glass covering, and inside the glass covering you have the filament, and this is our topic. This filament is our interest. So this is the filament. Now, what is this filament made up of? This filament is made up of tungsten. ये बना है tungsten से. Tungsten is a metal, my dear student, and not an alloy. Okay. And what is the symbol of tungsten? The symbol of tungsten. What is the symbol of tungsten? Pause the video and write the symbol of tungsten. Yes. What did you write? Did you write T? No, it's W. Okay. Many students think that it will be T, but no, it's not T, it's W. Okay. Now, reasons why tungsten is used to make this filament. There are two big reasons. Okay, two very important reasons. The reasons are, let me write down the reasons here. Reasons why tungsten is chosen to be the filament in an electric bulb. The reason number one is because of its very high melting point. Tungsten, of all the metals in the world, tungsten has got the highest melting point. What is the melting point of tungsten? 1000? 2000? Because highest melting point, no? Or 3000? Or 4000? What is the melting point of tungsten? Anybody? Yes? Please, anybody? Yes, 3380 degrees centigrade. 3380 degrees centigrade. This is the melting point of tungsten. Tremendously high. This is just the melting point. Just to melt, you have to supply this much heat energy. And water boils at 100 degrees centigrade, and that is extremely hot for us, isn't it? Okay. Now, on this note, temperature of lava. Does anybody know the temperature of lava? Because I want to throw tungsten there in the lava, hot molten lava, and I want to know whether the lava could melt tungsten or not. Okay, still very childish. Okay, I want to do this kind of silly things. Okay, so what is the temperature of lava? 4,000, 6,000, 10,000, 90,000. Okay, it's 1,200 degrees centigrade. Disappointed, na? Disappointed, is not? Is not? The temperature of the lava is not even higher than the melting point of tungsten. So now, what if I throw the tungsten in the lava? What will happen? Nothing will happen to the tungsten because the temperature of the lava is lower than the melting point of tungsten. So the tungsten will still be there. I can pick up the tungsten again. So disappointed. I thought lava was the hottest, but tungsten wins. Yay! Tungsten is the winner. He's the winner. Okay, he wins. So we should be like tungsten. Okay. So high temperature 3,380 degrees centigrade. All right. One of the reason is because of high melting point. Number B, it has got very high resistance also. So the second point, okay, the second point is because of its very high resistance. So because of these two reasons, tungsten is used as the ideal candidate for becoming the filament. Now let me explain to you in detail what actually happens here. So a lot of current passes through the filament. Now current means charged particles, but the filament has got very high resistance. So this will oppose. If it opposes means collision is taking place. Multiple collision is taking place. Multiple collision taking place means tremendous. Okay, and we are talking about a huge value. Tremendous amount of heat energy is produced, and that explains how the bulb is able to generate heat energy. Okay, because of the opposition, because of the collision. Now things don't stop from there. Okay, things proceed. Now because of the resistance offered by the presence of the resistors. Okay, now what happened? The temperature in the filament keeps on increasing, and the temperature in the filament increases to such a level that it starts producing its own light. Okay, this is the most unique feature about the bulb. Okay, and Thomas Alva Edison understood this, and then that's how he designed the bulb. So interestingly, what happens when an object, absorbs a lot of heat energy? When the temperature of an object keeps on increasing from 1,000 to 2,000 like that, it keeps on increasing, 2,100 to 2,200, it keeps on increasing like that. Okay, I don't know exactly what temperature, but then what happens when the object starts absorbing a lot of heat energy? What happens? The object starts glowing. The object starts producing its own heat energy. That means they get the property of self-luminescence. Self-luminescence. I'm not sure of the spelling, but please forgive me if the spelling is wrong. But this is okay when an object carries tremendously huge amount of temperature in them, the body starts producing light. This is the property of self-luminescence, and this is the same principle by which the sun is also giving out light, and all the other stars in the galaxy, they are able to generate their own light because of the high temperature in them. Okay, so if you can retain such values of heat, then even you will give out heat, you will give out light energy. Understood? So self-luminescence, and this is how the bulb gives us two forms of energy: heat energy and light energy. All right, I hope you understood. Okay, then we will go to the next point, which is we'll discuss the second object, which is the fuse. So next we'll study the fuse. So a fuse wire is made of an alloy of tin and lead. So SN and PP. So remember, my dear students, that a fuse wire is not a pure metal. Okay, a fuse wire is made of an alloy of tin and lead. Now, why an alloy? We use an alloy because we want the fuse wire to have very low melting point. Okay, there are reasons why the fuse wire should have low melting point. Okay, we'll be discussing this. So a fuse wire, the properties of a fuse wire are, it should have very low melting point, and it should be very thin. So it should be thin. Okay, we don't use a thick. We don't use a thick fuse wire. We go for a thin. Wire. Plus, it has to have low melting point, for which we are using a alloy. Okay. Now, next point, a fuse wire can carry only a specific value of current. Very important. This is a very important statement. Okay, this is a very important statement. Remember this, my dear students, that this fuse wire can carry only a specific value of current. So if it can carry only a specific value of current, what if a current beyond the specific value of current tries to pass through the fuse wire? What will happen to the fuse wire? Then if current beyond the specified value tries to pass through the fuse wire, it will melt and break. So let's write on that. Beyond which it will melt and break. See, so this fuse wire can only carry a specific value of current. So if current more than the specified value tries to pass through the fuse wire, then the fuse wire will melt and break the connection. Okay, so now why do we even use a fuse? Let me explain to you. So a fuse is very important. Now you see, let me just draw here. So our wires are like this. Let's say our wires are like this. So we use thick wires in our home, okay, so that they can bring quite a good amount of current, so that electrical appliances present in our home can be run, okay, because these devices, they demand a lot of heat, electrical energy. Now, being thick, okay, what happens is that they bring a lot of current. Now, also remember this, okay, a fuse is always connected in series in the circuit. So what we will do is, in the main wires, we will break the main wire into two parts, okay, and then in between, what we will do, we'll connect the fuse. So this is the fuse, okay, this is the fuse wire, this is the fuse wire. And remember the properties, I have already erased it, sorry, but then the properties are, this has got low melting point, okay, so this fuse wire has got low melting point. Now what happens is that sometimes, okay, this wire brings a lot of current. This wire comes from the main, okay, this wire comes from the main line. So sometimes this wire, which has got direct connection to the main line, it brings a heavy load of current. This is called overloading. So it brings a lot of current, okay, it tries to bring a lot of current to our home. Now had there been no fuse, this and this wire are joined, isn't it? So the connection is there, so this extra current, this overload current will come to our home, and then chances that it will destroy our appliances are there. But we don't know when this will happen, isn't it? We don't know when this will happen. So what we do is we use a fuse. Now using the fuse here will prevent this from happening. How? When this overload current tries to pass through the fuse, what will happen? Since the fuse is designed to handle only a specific value of current, what will happen? When this current tries to pass through the fuse, the temperature of the fuse wire will increase suddenly, and then it will melt and break. So it will melt and break, thereby breaking the connection, okay. So now the circuit is broken. So what will happen? That extra current, that overload current, which was heading towards our home, now it will go back to the main line and it will travel around. So did the fuse not save our home from damage? Did the fuse not save your home from getting burned down? Because houses have been burned out like this. So you see how important the fuse is, okay. So this is the second device, okay, which works on the principle of heating effect, okay. Now we'll erase this and we'll discuss the third point, which is a very important point. We'll discuss the heating element or the heating coil. So the third device is heating element or coil. So heating element or coil. Where are they used? They are used in those appliances which gives us heat. Examples of such appliances are geysers, toasters, iron, okay, rice cookers, etc. Let's write down those examples. Example: geysers, toasters, then electric kettle, then iron, then rice cooker, oven, etc. Okay, so present in all of these appliances we have the heating element. Okay, the heating element are present in all of these appliances. Inside the rice cooker, I have seen the heating element. It is somewhat spiral in shape like this. Okay, it is like this. So this is the heating element present inside the inside the rice cooker. You can say spiral or you can say coil, because the mosquito coil is also almost in this shape, isn't it? So remember this. Now, what is this heating element made up of? So the heating element is made up of nichrome. Nichrome is the most widely used element for making heating element. Okay, nichrome is the most widely used substance for making heating element. So is nichrome a pure metal or an alloy? Remember class, nichrome is an alloy. So nichrome is an alloy. Nichrome is an alloy of nickel and chromium. Now, there is a good question. Okay, there is one very important question which can be asked from this, and that is, why are alloys, okay, used as a heating element and not a pure metal? Then the answer is, alloys are used as an heating element and not a pure metal because alloys have high resistivity. Having high resistivity, they have got high resistance, and having high resistance, they give out tremendous value of heat. They give us tremendous amount of heat. So this is the answer. So an alloy, because they have got high resistivity. Okay, resistivity. What is resistivity? Resistivity is a property of a substance to oppose charge, is not to oppose current. So alloys have high resistivity. Having high resistivity, they have got high resistance, and having high resistance, they can give us tremendous amount of heat energy. So this is the reason why alloys are preferred over metal. Okay, so basically what happens is that when current passes through the heating element, the current experiences tremendous amount of resistance, okay, which leads to the generation of tremendous amount of heat energy. So this is it, my dear students. The topic is over. Okay, so before I end the video, I have a question for you which I want all of you to participate. So the question for today is, which substance would you choose to make a heating rod? The options are insulator, conductor, option C, resistor. Kindly give the answer in the comment box. Now, it doesn't matter, my dear students, whether your answer is correct or wrong. What matters is your participation. Okay, so I will go through your comment and let you know. So this is it, my dear students. Thank you for tuning in and watching the video. And another video will be up very soon. The video will be on electric power. That will be the last video on the chapters, and after that I'll be uploading videos on numericals. So I want you all to tune in again and continue learning. Okay, so this has to continue. If we continue this, then I guarantee you, okay, you will get good marks, and at the same time you will understand science better. So once again, thank you all for tuning in, and I'll see you again in the next video. Until then, take good care and have a great holiday.